Hey guys, these are going to be the notes from Wednesday. The recording we did that day got corrupted somehow, so just re-recording. First derivative test, this is day 2 examples. So number 3, the first one we did that day was f of x equals 2x plus 8 to the 5th times 2x. Okay, your instructions are to find relative extrema. Remember, extrema means both mins and maxes. Okay, so the first thing that I want to point out to you is that when I'm looking at that function in particular, it's going to need product rule. So obviously this is going to be the first part of my product. That's the second part of my product. And I'm going to set it up down here. So my u is going to be 2x plus 8 to the 5th. My v is going to be 2x. Well, then my u prime, the 5 comes down to the front. 2x plus 8 is now to the 4th. But then remember, because of chain rule, my core here, 2x plus 8, has a derivative other than 1. So the derivative of 2x plus 8 is times 2. My v prime for 2x is 2. So from there, we're going to take our derivative by multiplying the products of the diagonals. I'm going to do this one first. So f prime of x equals, and then I'm going to combine all 3 of these constants. So I have a 5 here, multiplied by 2 here, that's 10, multiplied by 2x here, that's 20. So I have 20x, and then I have 2x plus 8 to the 4th plus. So that's my first diagonal. Okay, second diagonal, I have 2 times 2x plus 8 to the 5th. Alright, so here we go. From here, setting this equal to 0 to find my critical numbers. I notice that I have a GCF of 2x plus 8. I have 4 of that term here. I have 5 of that term here. That means I can pull out 4. Also notice that my 20 and my 2, I can also divide a 2 out. So to the front, I'm going to take a 2 and a 2x plus 8 to the 4th power. Then whatever's left over, I'm going to leave it in a bracket in the back. So 20x divided by 2, that leaves me with a 10x. Then I had 2x plus 8 to the 4th, but I pulled all of those out to the front, so there's nothing left over from this term. Second term, I took the 2 out. 2x plus 8, I took 4 of them out, but there's a 5th one, so I have another 2x plus 8. Okay, well then I look at my leftovers bracket and I see that my 10 and my 2x here, those can combine. So that's going to give me 12x. So I have 2x plus 8 to the 4th, and then I have a 12x plus 8 here. Now, at this point, remember, we're set equal to 0. We're looking for our x-intercepts or whatever. So I want to factor out common denominators, common factors. So out of this term, I see I can pull out a 4. It's going to leave me with a 3x plus 2 left over when I take the 4 out. Okay, then from the front, I have the 2 that's already there. Okay, but when I want to pull a 2 out of this, notice 2x and 8 can both divide by 2. I have to be really careful in the way that I do that. So when I divide the 2 out, it's going to give me an x plus 4 left over to the 4th. But when I take a 2 out, I'm taking 1 out of each of the 4 terms. So I'm really pulling out a 2 to the 4th. So 2 times 2 is 4, times 2 is 8, times 2 is 16. Multiply by this 2 over here. That's really a 32 in the front. X plus 4 to the 4th. Then another 4 over here, and a 3x plus 2. Okay? Now, you could have actually left it like this. Instead of changing it to a 32, it's really just up to you what you like better. From there, my first critical number is going to give me x equals negative 4. My second critical number, change the plus 2 to a minus 2, then divide it by 3. So, set up your line chart. Negative 4 is the smallest, negative 2/3 is a little bit larger. Okay, I want to pick a number that is to the right of negative 2/3, well, I'm going to pick 0. Now remember, when I plug in 0, Okay, I'm plugging that into this. So I would have 32 times 0 plus 4 to the 4th times 4, 3 times 0 plus 2. Okay, we'll think about 32 is positive. 0 plus 4 is positive, 4th power is still positive. And then 3 times 0 is 0, plus 2 is positive. So if I multiply 3 positives there, I'm going to get a positive. Okay, between -4 and -3, let's say I decide I want to pick -2. Okay, well then I'd have 32, -2 plus 4 to the 4th, times 4, 3 times -2 plus 2. Okay, we'll think about 32 is obviously positive. -2 plus 4 is positive. Raise it to the 4th, still positive. This is a -6 plus 2 though in here. And -6 plus 2 is negative. So if I have plus, plus, minus, overall my middle interval is negative. Last sub-interval, say I pick maybe negative, we'll do 6. So I'd have 32, -6 plus 4 to the 4th, 3 times -6 plus 2. Okay, let's think about our numbers there. 32 is obviously positive. -6 plus 2 is -2. But then if I raise it to the 4th power, that's actually going to turn positive as well. Because I'd have -2 4 times, so they'd cross out the first 2 and the second 2. Okay, then from here, that's -18 plus 2, which comes out to be negative. So I have plus, plus, minus again, which means that interval is negative. So remember, those are the signs for f prime. F prime tells me what regular f is doing. When f prime is negative, f is decreasing. Negative again, still decreasing. Positive is increasing. That makes this one a minimum, and that makes this one a neither. Now, the other thing I want to point out to you, hopefully you noticed this, but if you didn't, it's okay, is that when I look at my x plus 4 term, I notice that it has a 4th power. Okay, that is called an even root. Okay, remember that if it's squared, we call it specifically a double root. But 4th, right, you'd consider it an even root. And remember that even roots, you're going to see no sign change on your line test. So when I look at -4 here, I expect these to both come out to be negative because it was an even root. That means no sign change. Okay, so from here I would put at x equals -4. It is a neither a max or a min because f prime does not change sign. At x equals -2/3, we have a relative minimum because f prime changes negative to positive. Okay? So remember, for a minimum it changes negative to positive, for a maximum it changes positive to negative. All right, let's turn over to the back side. We got 2 more examples left. Okay, so we did a product rule example. Now we're going to do a quotient rule example. So our function is going to be x squared plus 5. This is number 4. Over x minus 2. Okay, your instructions are the same. You want to find relative extrema. Okay, so first thing I need to do is take the derivative. I know that's going to...
Good morning, Rams fans, and happy homecoming! At this time, will the band and drum line please make your way to the gym for the pep rally? Thank you.
Okay, so high is going to be the numerator, which is x squared plus 5. Ho is going to be the denominator, x minus 2. Then I need to take the derivative of the top, derivative of the bottom. So the derivative of x squared plus 5 is 2x. The derivative of the bottom is just a 1. So now we're ready to set up our derivative. So f prime of x equals, remember it's ho d high first, that's these two. So I have x minus 2 times 2x minus, then I need high d ho is x squared plus 5 times 1. Okay, and then the 1, I'm not going to put that. Okay, then all divided by ho squared, which is x minus 2 squared. Okay, now there is a big mistake that I've made that's going to end up messing up my answer if I don't fix it now. So I'm going to give you a second to look and think of what it is. Okay, it should be, boom, parentheses. Remember that those parentheses matter in quotient rule because I'm subtracting both of these guys. So that negative is going to need to be distributed into those terms, just like I'm going to distribute my 2x into the front two terms. So just kind of keep that in mind, quotient rule. If it's a multi-term thing for ho or d high or any of those, you need to make sure you put them. Okay, so 2x times x is x squared. 2x times minus 2 is minus 4x. Then I have a minus x squared from in here. Oops, I forgot to write my 2. That was a 2x squared, and then a minus 4x. Minus x squared, then minus 5. All divided by x minus 2 squared. Okay, from here, I notice I have some like terms on the top. I can combine this x squared by taking it away from the 2x squared. So 2x squared minus 1x squared is just an x squared. Then a minus 4x, then a minus 5. Now, when you have a derivative that is a quotient or that has a fraction, you need to factor the whole thing. So from the top, I need numbers that multiply to negative 5 and have a difference of negative 4. I'm going to use x minus 5 and x plus 1. X minus 2 squared is still on the bottom. And then if you look back to your instructions from Monday, remember that critical numbers are values of x that make f prime of x equal to 0 or f prime of x equal to undefined. So think about, if you want f prime to equal 0, you're going to let the top equal 0. And if you want f prime to be undefined, you're going to let the denominator equal 0. So what that basically means is that instead of me only picking my fractions from, or my factors from the top, I'm going to also have to include that bottom root as well. So my critical numbers, I'm going to have 3. Okay, my first critical number is going to be x equals 5 and negative 1. Those are both from the top. And then my bottom critical number would be a 2. Because if I plugged in a 2, I'd have 2 minus 2 on the bottom, which makes it undefined. From there, set up your number line test. Negative 1, 2, 5. Pick a number a little bit bigger than 2. Say I pick 3. Okay, as I plug in, we're going to do a little bit of this in our head. Okay, so remember, actually, let's pick a number bigger than 5. Say we pick 6. So I'd have 6 minus 5. So 6 minus 5 comes out positive. 6 plus 1 comes out positive. And then 6 minus 2 comes out positive. Divide 3 positives, get a positive. Okay, next term. Smaller than 5 but bigger than 2. Let's say we pick 3. 3 minus 5, negative. 3 plus 1, positive. 3 minus 2 is positive. Square it, still positive. So negative plus plus is negative overall. Other side of 2, let's say I wanted to pick maybe 0. Okay, 0 would be about right here. 0 minus 5 is negative. 0 plus 1 is positive. 0 minus 2 is negative, but then I have to square it. So that bottom is going to be positive. Negative plus plus overall is negative. Okay, last subinterval. Smaller than negative 1, say I pick negative 2. Okay, negative 2 minus 5 is negative. Negative 2 plus 1 is also negative. Negative 2 minus 4 is negative, but then I'm squaring it again. And when you square a negative, you're dividing by a positive. So minus minus plus comes out positive because these two guys cancel out with each other. Okay, from there, that's your f prime. Let's see what's happening for f. So my f would be increasing on the intervals where f prime is positive. It would be decreasing on the intervals where f prime is negative. Which means I have a relative max at negative 1. I have a relative min at 5. Okay, from there, I would say at x equals negative 1, I have a relative maximum because f prime changes plus to minus. At x equals 5, I have a relative minimum because f prime changes negative to positive. Now, I want to take a second just to talk about what happens here at 2. So 2 is obviously a neither, okay, because it goes from negative slope to negative slope, so down to down. So that doesn't count as either, but I want you to think about why that happened. Look back at your original equation here. If I have x minus 2 and it's squared, that means that 2 is a double root. Okay, and remember, for double roots, you know you're going to have no sign change on your number line. Okay, so that's just something to think about. If we had recognized that from the beginning, I could have skipped this interval and just marked it as a negative to match that side. Okay, the other thing I want to talk about is what happens at 2. So sometimes your neithers, your graph goes down, then it flattens out, and then it keeps going down. That's one type of neither. That is not what happens here. Think about it. If I were to plug in 2 to my original equation, let's come back up here. If I were to plug in 2 to this, 2 minus 2 gives me a 0 on the bottom. That means there's actually an asymptote there. So that means that what happens is that maybe my graph has an asymptote going down, and then it starts off coming off of an asymptote down again. Okay, so at x equals 2 for this graph, I actually have a vertical asymptote because x squared plus 5 over x minus 2, I would get a 0 here. Gives divide by 0 at x equals 2. Okay, so that's just kind of something for you to maybe understand. Okay, that 2 here is not a flat spot. It's an asymptote, because if I try to plug 2 back into my original, I get a divide by 0, and divide by 0 means it's an asymptote. Okay, one more left. All right, last one. Y equals x plus 4 over x. And then remember, same instructions, find the relative extrema. So the first thing I'm going to need to do here is a rewrite. So x plus 4x to the minus 1. I'm going to have to pull that x up to the top. We don't want to leave it on the bottom. From there, I'm ready to take the derivative. Y prime, the derivative of x is a 1. Then from my derivative here, I bring my negative 4 down, or I'm sorry, my negative 1 down. Multiply it by 4, that's a negative 4. Take away 1 more from the power, x is to the negative 2. From there, I'm going to do one more rewrite on that. That's going to be 1 minus 4 over x squared. So these are really the same. This is still just y prime. Now, remember what I said before. You have to have one big fraction if you have any part of your thing that's a fraction. So what I'm going to do is get a common denominator. So I'm going to multiply my 1 by x squared over x squared. And the reason that I'm doing that is that now on the top, I have 1x squared, well that's just regular, minus 4, and then over x squared on the bottom. And then I notice that this up here, that's a perfect squares, I can factor that. So when I factor it, I'm going to get x plus 2 and x minus 2. Then on the bottom, I still have an x squared. And then remember that your critical numbers come from the top and the bottom. So off of the top, I have a plus 2 and a minus 2. So x equals negative 2 and positive 2. But then my 1 from the bottom, my x is kind of by itself. That means that 0 is my third factor. Now look at your equation carefully. Which of those is a double root? I see a squared here. Remember, that guy is a double root. And so a double root means that when I make my sign chart at 0, it should not change sign. So negative 2, 0, 2. Okay, number bigger than 2, maybe I pick 3. So 3 plus 2 here is positive. 3 minus 2 is also positive. Divide by 3 squared is positive. Overall, positive. Between 0 and 2, maybe I pick 1. 1 plus 2 is positive. 1 minus 2 is negative. 1 squared is positive. Okay, plus minus plus, overall is going to be minus. And then since 0 is a double root and there's no sign change, I can copy the minus across to the other side. Then smaller than negative 2, say I pick negative 3. Plug that in here. Negative 3 plus 2 is negative. Negative 3 minus 2 is negative. Negative 3 squared, though, is positive. Negatives on the top cancel out. Positive on bottom leaves it positive. So I have increase, decrease, decrease, increase. I have a max here. I have a min here. Okay, in the middle, remember, I have a neither. So let's write our conclusion. At x equals negative 2, you have a relative max because f prime changes plus to minus. At x equals regular 2, you have a relative min because f prime changes negative to positive. At x equals 0, you have a neither because f prime does not change sign. Okay, then I'm going to add to that there is a vertical asymptote. Oh, oops, I forgot to talk about this. We talked about it on the last one, but why am I saying that 0 is a vertical asymptote? I want you to think about what we said last time about vertical asymptote. If I were to plug in 0 way back to the original, so I'm going to come up here, look at your equation. If I were to plug in 0 plus 4 over 0, I get a divide by 0. And remember, divide by 0 means that there's an asymptote. Okay, vertical asymptote because x plus 4 over x gives divide by 0 at x equals 0. Okay? So remember, whenever you get a 0 on the bottom, that should be telling you that you have a vertical asymptote at that point. Okay? Good job.